Fashion Tech Alliance involves higher educational institutions, small, medium and big enterprises and the research center. This project has been co-founded by the Erasmus Plus program of the European Union and is aimed to facilitate knowledge exchange between partners and to design and pilot learning experiences to engage students in a fashion tech residency program, embedding young talents in the company's innovation activities. A central objective of the project is to design multidisciplinary, interdisciplinary and intersectoral learning activities involving international students from 5 European universities. The contents of the lectures have been specifically created to match the needs of fashion tech learning. They have become open educational resources to allow future engagement between a European-wide fashion and textile HEI community and are available under Creative Commons Sharealike 4.0 with the aim of a wide and free distribution, access, use and reuse. Ready to learn more about fashion tech? Enjoy the lecture.
So, hi everyone, today we are here for a module on traceability and more precisely the traceability along garment production supply chain. My name is Bixente Demarcq. I'm a circular economy engineer. I'm working at ESTIA in a platform which name is CIRCULARITY, and we are working on textile recycling and shoe recycling. We are developing solutions for industrials like DECATHLON in order to make the circularity concrete. In this module, there is several objectives, like knowing the different stage in the garment production supply chain, knowing the challenge and of traceability and the return of data to the consumer, knowing technologies which increase transparency and traceability. So for this module on traceability, we will start by asking why is there a need for traceability, and then we will talk about the issues identified around traceability and the expectations of consumer. We will discuss the textile supply chain and its complexity. We will see the technologies that allow us to have this follow-up in the textile supply chain. And finally, we will see how these traceability technologies can represent an opportunity for circularity. So first of all, the context, why is there a need of traceability in textile supply chain? Firstly, there has been an increase in consumer awareness of the environmental and social impact of their consumption patterns. It started with the Rana Plaza collapse in April 2013. During this month, in the suburbs of Dhaka in Bangladesh, the building collapsed, killing more than 1,000 people and injuring around 2,000 people. The building housed textile and garment factories which supplied multinational clothing companies. Among the ruins, labels from brands such as Auchan, H&M and Mango were found, but evacuation instructions have been given the day before after cracks appeared in the wall, but they were ignored by factories managers. So after this tragedy, the Fashion Revolution Collective was created. It aims to raise the public awareness of the impact of the fashion industry and in order to ask in the sector for more transparency in the supply chain, and they created an hashtag which is Who Made My Clothes, and more recently another case has emerged, that of the forced labor of Uyghur community in 2020. A report from NGOs And think tank denounced the exploitation of Uyghurs in fields, workshops, and factories supplying raw materials or finished products. Brands like Nike, Adidas, Calvin Klein, Zara, Victoria's Secret, and Lacoste were accused in March by the NGO Australian Strategic Policy Institute of having sourced potentially directly or indirectly um, from structure using Uyghur labor from re-education camps. These various events have contributed to the demand for transparency about among product consumers. So, moreover, as we can see, there is a lack of information in garment labels. In fact, when we go to a shop and we build a new clothes, there is no information about product environmental footprint and product social footprint. We only can see information such as the place of production, the composition of the clothes, or the size. We have an example there, but it's in order to know the question or to think about the question, how can the environmentally conscious consumer know which garment has the lowest impact? When we see these two data for the two different t-shirts, the answer is he don't know how to choose which t-shirt choose. So we identified an issue, which is the fact of giving to the consumer or to sharing with him more information, giving him a better communication on the impact of the garment he will buy. And we can ask how to achieve that issue. In order to achieve that issue, people or brands should promote transparency and traceability on working conditions in material and product factories, companies and suppliers involved in the production supply chain too. Use the materials environment impact, manufacturing process, transportation. So in order to have all these informations, we identified that there is a need to track informations all along the supply chain, and not only in the last steps of production of the garment. So now we will speak on garment supply chain. But there is a lack of transparency in textile supply chain. In fact, fashion supply chains of large fashion brands are typically complex global systems. Fashion companies work with farms, with ranch, and textile companies that grow, raise, create, dye, weave, and finish the materials. Most do not own their own manufacturing facilities, but instead work with hundreds of contact factories that can cut, sew, and assemble garments. So these successions of intermediaries in the textile supply chain makes it very complex. It is difficult to keep a reliable record of the different stage or intermediaries that raw materials go through before ending up in a product in a shop. It is therefore important to have one or more technological means to ensure this follow-up. This allows real monitoring of the product in order to carry out life cycle analysis and also to provide the consumer with certified information on, for example, the ecological or the social impact of the product he or she is buying. So now we will speak about these technologies that allow to have this certified information and this traceability. We have therefore created a graphic, a chart, where we'll put the granularity of the information to be collected, separating it by decreasing granularity. So granularity defines the size of the smallest element of a system. When we reach the level of granularity of a system, we can no longer slice the information. For example, in a garment, the granularity is a garment. So it's the unique cloth, as we can see there on the right, but we can have a bigger granularity or more larger, and going from production batch or garment range, or only having information on brands. So first of all, we'll speak on SUON labels, um, which are on every cloth. So most of the time, the information we can find on these labels are in the range of garment range. Um, Another way to transmit data to consumer are QR codes or barcodes. A barcode is a method of representing data in a visual machine readable form. It's in 1D instead of a QR code, which is a type of barcode that can be read easily by a digital device, and which stores information as a series of pixels in a square-shaped grid. QR codes are frequently used to track information about products in a supply chain, and they are often used in marketing and advertising campaigns. More recently, they played a key role in helping to trace coronavirus exposure and slow the spread of the virus. The first QR code was invented in 1994 by a Japanese company, Denso Wave, Toyota subsidiary. They needed a more accurate way to track vehicles and parts during the manufacturing process. Standard barcodes can only be read in one direction, top to bottom. That means they only can store a small amount of information, usually in an alphanumeric format. But a QR code is read in two directions, top to bottom and right to left. This allows it to house significantly more data. It's the main difference between barcodes and QR codes. So the granularity for this barcode and the QR code, we can go from the brand up to production batch, which is more precisely that the information we have on labels. Then we have RFID. RFID, radio frequency identification, is a technology that allows data to be stored and retrieved remotely on what are known as RFID chips or tags. RFID is widely used in the security sector. RFID technologies is based on electromagnetic energy transfer. To implement it, it is necessary to have markers, to say labels, tags, or RFID chips, also called transponders, and an RFID reader. The RFID reader emits a radio frequency that activates the RFID chip that pass by. To do this, it sends them the necessary energy at a short distance. Several frequencies are used depending on the performance and the type of application. Higher frequency allow more information to be exchanged at a higher rate, while lower frequency have the advantage of better penetration into the material. RFID tags are called passive because they use only the energy supplied by the reader. Today, some RFID tags can be read up to 2,000 meters away. Tags consist of an antenna, a chip, and an encapsulation or substrate. They are inexpensive, extremely discreet, and can be single-use or reusable. RFID chips can contain several types of information identification database. Now we will see a case study on RFID with Decathlon. So all Decathlon warehouse in Europe are equipped with tools to read the chips, the RFID chips, tunnels on the conveyors, masts that can scan and enter pallets, readers at the entrance to the sorting machines. This tracking covers the entire supply chain from manufacture to sale, right up to the hands of the consumer, who can erase this trace as soon as they pass through the checkout of the shop. For those who wish to do so, the chip can be deactivated on a request by asking a salesperson, a security guard, or by doing it yourself, but by placing the material in a bin designed for this purpose. And the time saved is considerable since the entire logistic chain is monitored. And for Decathlon, it's a strategic objective and a strategic issue, and it's why they used this RFID. It allows also to have to exchange data with the consumer. When they use a take-back process of the product to know more information on the product and its defaults in order to design it back and have a better product. So that's why it's important for Decathlon. So in the RFID, we can put all the information we want. So we decided to put it between production batch and unique granularity, because if we want, we can put all the information of the garment and where it's produced, and we just have to follow this information. Then we will speak on blockchain. So blockchain, what is it? Blockchain is a shared and immutable ledger that facilitates the process of recording transactions and tracking assets in business network. These assets can be tangible, like a car, an house, or intangible, like the intellectual property. A blockchain network makes it possible to track and exchange virtual any asset of value, reducing risk, lowering cost for all parts involved. So it's this last point that interests us. In fact, with the blockchain, we can exchange data, for example, virtual asset can be data, and so the consumer can go and see this data on the blockchain and being sure that the data is okay. So if you want to go deeper in blockchain, you have a link for a video at the right. It's interesting to understand better. And now we will see how it works concretely. So for the first point, each transaction is recorded as a block of data. These operations are or transactions show the movement of an asset, which can be tangible or non-tangible. The data block can record any information you like: who, what, when, where, how much, and even the condition, such as the temperature of a food shipment. Then each block is connected to those before and after it. These blocks form a chain of data as an asset move from one place to another or change ownership. Blocks confirm the exact time and sequence of transactions. They are securely linked together to prevent one block from being altered and or a block from being inserted between two existing blocks. And then in a third time, the transactions are located together in an irreversible chain, so the blockchain. Each additional block reinforces the information of the previous block and thus of the whole blockchain. The blockchain is therefore inviolable. This eliminates the possibility of tampering by a malicious actor and provides a record of transactions that you and other network members can trust. So it's important to remember that all information entered in the blockchain, even if they are true or false, are unmodifiable and can be read by all. The interest would thus be to put verified information during the various stages of the production to allow a total transparency. This is in line with the idea of a digital twin of the Decathlon product we've seen before. So the granularity of the blockchain could be on the unique product if we put data on it. We have a perspective about the traceability for circularity. In fact, today traceability is synced in the same way as the product, linear. Tomorrow, as for the product, it will be necessary to be able to make this evolution. Product traceability will be a tool for circularity. Indeed, at the end of the first life of the product, when it is brought back to the shop and goes to the sorting center, it will be important to be able to identify it in order to know its composition or the way to dismantle or repair it. Here we are not talking about the same information as traceability for the supply chain. We are talking about information like the characteristic of the product and not necessarily the way it was produced or where it was produced. It is in this sense that developing a digital twin of the product is interesting. We will have all the information for the brands, the consumers, and the centralized recyclers. This will allow a large amount of product data to be fed back. So as we can see here, the need to maintain product traceability up to its end of life in order to allowing it to enter in circular loops. So in conclusion, as we've seen in this course, traceability and transmission of information to consumer is a key issue for brands. And the choice of technological solutions will depend on the level of information to be transmitted to the consumer. The more we want to share information on unique products, the more we will favor advanced technological technological solutions such as the blockchain or RFID. This choice must be made by the company according to the information transmitted. Thank you for participating to this module.